guys, sorry to interrupt your video. Just a quick plea, subscribe to my channel please. If you haven't done it already, subscribe. Tell your friends, subscribe. Thanks. Weight. The more weight you have, the more energy it takes to accelerate it, therefore the more fuel you burn. Every 45 kilos removed from the car can save you 1 to 2% on fuel consumption. Your average car has about a 60 litre fuel tank. It does vary quite a lot actually, but it's about that. And diesel is about 0.85 kilos per litre, petrol 0.75, so therefore a diesel tank is about 51 kilos and a petrol is 45. Right, just so you know, not mega important, you're not asked that question, but it's just for so you know what you're dealing with. In fact, the RAC suggested half filling for economy if you only drive around town and love spending time at petrol stations. Clearly, I can see where they're coming from. If you've got a big tank, why burn fuel just carrying the tank around? That's what they're getting at. But it is only 1 or 2%, so I'm just making you aware. I'm not saying it's good or not. Just cruising around town, the weight won't make much difference if you drive sensibly and accelerate and using fuel cut-off all the time. If you stop-start, that's where you burn the most. However, when you are accelerating or particularly going up a hill, extra weight will have a significant amount on fuel consumption. You have to push the accelerator so much harder to get the car to perform the way you want it to perform when there's weight in the car, and the harder you push it, the more fuel you burn. All right. 3 extra people in the car will cost you about 10% in fuel overall, roughly. Let's say it's 1 to 2% for a 45. Most people get a couple of fat mates, sort of 90 kilos, that sort of thing. There's your 10% just by carrying your mates around in the car. Right, air conditioning and other electrics. Okay, so there are many theories on this topic, and there are loads of places that say the generally accepted wisdom of this sort of stuff, but then I also had a look and found some specifics. All right. So in a car, the way a heater works is it just blows a fan across a radiator into the cabin, right? So I mean the radiator's there anyway, it's not doing anything, it's just a fan blowing, so it doesn't actually have a very much economy impact on your car, fuel economy wise. All right, having a heater in the car is fine. Normally via a belt connected to the engine directly, air conditioning is a compressor that takes power from the engine to run. So when you press that button, the compressor is physically connected to the engine, and it takes about 8 to 12 horsepower to run air conditioning. If your 1 litre Nissan Micra only produces 50 horsepower at maximum output, 10 horsepower is 20% of your engine being used just to keep you cool before you even get going. If you obviously had 200 horsepower, it's only 5%. It's a very much smaller percentage, so the more powerful and the bigger your engine, aircon has a smaller impact on it. But if you've got a little engine, it has a big impact. My first car, decent one, I did buy some old pile of junk when I first started, but my first decent one was a Nissan Micra, and I turned off the aircon to help me accelerate onto motorways. And then I put it back on when I got on there, and I really noticed it. You accelerate just thinking, come on faster, switch off the aircon, and the car would accelerate better, get up to 70, put it back on again. It made a difference. Remember that an engine produces more power the higher the revs. So as your revs climb, you get more power. So therefore at low revs, there isn't much power being produced. So low revs, engine may only produce 10, 15, 20 horsepower. And so aircon can be using 50% of the available power just to cool you down. I mean, just open a window, all right? If you're at low revs, just get the window open, let the heat out. In summer, your car can be blisteringly hot. I have actually seen videos where chefs have actually cooked a roast just by putting the roast in a car and leaving it in direct sunlight, which is why dogs die in cars, is because it's hot enough to cook a roast in a car. Right? Rather than trying to cool a car from 60 degrees down to 17 using aircon, open the windows, let 35 degrees out of the car, then use the aircon to cool from 25 down to 17 rather from 60 down to 17. Far more efficient. Just open the windows, start driving to let that heat out, let the air whip through the car, and once the temperature's got down to a more respectable level, then you can close the windows and use aircon if you want. It's much more efficient to do that. Generally accepted wisdom is there is also aerodynamics to consider. So generally accepted. A closed window are aerodynamics. The wind will go smoothly round the car. An open window is called buffeting. You know when you're in a car and your ears are going ow, ow, ow. Right. So the air is going in and out and therefore will cause more drag, which uses more fuel. And the crossover, where you've got fuel economy versus wind resistance and stuff, is 40 miles per hour. If you really need to cool down, it is more efficient to use aircon above 40 miles per hour with windows closed, but open windows below 40 with no aircon. So at 40 miles an hour, less than 40, just have the windows open. Above 40, from the buffeting point of view, run it with aircon. That's the generally accepted wisdom, right? However, Auto Express did do a test at high speed and found that the open windows only affected fuel economy by 0.1%. That was in their Astra. Maybe it's car specific. Maybe. Don't know. I mean, I can see why people say what it is and it makes sense, but in actuality, Auto Express didn't find that to be the case. So that's a good excuse for driving around with the windows open all the time. According to the Energy Saving Trust, aircon becomes more efficient above 60 miles per hour. At slow speeds and at low revs, aircon eats fuel. You might as well set fire to your wallet. That's what I was saying earlier on. If it takes 10 horsepower and your car at idle is only producing 15, then or 20, then half of your power is just trying to cool the car rather than move the car. So therefore it has a mighty impact. But the more your revs come up, the more power is available. So therefore the impact that those 10 horsepower have on the car is significantly smaller because there's more horsepower around. Motorway driving, aircon has hardly any effect on fuel consumption. That's what they found. It's because your revs are higher. You got more power. Just a maintenance tip here. All right, aircon takes moisture from the car and then chucks it outside, right? Which means the internal sections of the mechanism are wet. It is generally accepted to run or recommended to run your aircon at least once per month, even in the winter months, to stop bacteria building up in this wet environment. If your aircon smells when you use it, it's full of bacteria. You can actually get canisters that you release in the car and run it through and it kills the bacteria off, or just frequently run your aircon and it will kill the bacteria off. Right? Other electrics: heated seats, heated windows, heated steering wheel, heated this, that and the other. Right? In a car, you've got a battery to start the car and run anything electrical. There is an alternator that charges the battery when the engine is running. The more it has to charge because you took it away from the battery, the more it takes power from the engine and therefore it uses fuel to charge the battery. Right? Fine. The amount of drain from these items is negligible, so when you're running it, it's not really going to have an impact on your fuel economy. But it will affect you if you use a lot of short journeys. So starting a car uses a lot of electricity. When you turn that key and the starter motor fires up, you take a lot from the battery. They're powerful things, car batteries. Then you add on anything electrical, you're taking charge out of that battery. Right, so you've got a battery and we're just using that power. So logically, therefore, if you have a short journey, the alternator hasn't run fast enough to replace what you've used. Make sense? If you go for a long drive, it's got loads of time to recharge your battery up to full strength again. If you never drive long enough to recharge the battery, one day it will be flat and you can't run it because every time you start the car you use more than you're putting back into it. It's just common sense. So yes, in the great scheme of things, you burn more fuel to run these items, but from a fuel economy point of view, they don't really have an impact. You're just running the alternator a little bit longer, but it can have an impact regarding booting the car up. So to conclude, air conditioning makes a big difference when driving at slow speeds, but has very little impact on the motorway. Having the windows up or down makes very little difference. A modern aerodynamic roof box barely impacts on fuel used, but non-aerodynamic roof thingies are awful, as in a roof rack, for instance. Slowing down on the motorway will boost fuel economy dramatically. We were seeing there 15-30%, you know, so it will make a difference. Get the car regularly serviced. Low tyre pressures impact fuel economy. The biggest impact is how you drive though, so drive in an eco-safe manner. So accelerate, then don't use that accelerator very much. Cruise along, use fuel cutoff to cruise into junctions. Don't just drive around, just drive economically, and you can boost it by 50%. Look long, plan in advance, accelerate gently, and use fuel shutoff. It makes a big difference. Right, the theory test questions can come up with different figures. Okay, you are asked often in these questions how much fuel can you, or how much fuel. Let's say that. Start again. You are asked how much more fuel would you burn at 70 miles per hour than 50 miles per hour, and depending upon the question, the answer can vary between 15 and 30%. If you actually look in this book, it says 30. If you do the theory test questions, it says 15. Okay, but don't forget, all the figures quoted in books and online and stuff like that are dependent on a lot of variables, such as what car they were driving, how much wind resistance there was that day, was there any hills involved, was there traffic lights, blah blah blah, right? Lots of variables. So I just need you to look for a figure, if they ask this question, in the region of 15 to 30 roughly, and that should answer it. Okay. Always consider others though. Driving too slowly in fast moving traffic is dangerous. Yes, you can save money and the planet, it's a good thing, but not if you're inconveniencing or endangering other road users. So if you start to decide to pull onto a dual carriageway doing 40 miles an hour to save fuel, you're going to get wiped out or die because some other car smashes into the back of your car. Alright? All these fuel economy things, use them where you can, but not at the expense of other road users or endangering anybody. Alright? That's it. Thank you very much. Don't forget to subscribe to my channel for more videos. Thank you very much. Take care. Bye.